It's been a while since I've done a video, so this is kind of a break-in introduction. I moved from my basement upstairs, so we'll see how this new setup goes. I want to talk real quickly about the diatomic species, and an easy way to remember those is Hofbrinkel. So as you look at this, another way to think of it is Han and the halogens. I just realized the other day when one of my students asked me who this was named after that my concept wasn't super clear. All this is a mnemonic for remembering which species are going to be diatomic. So hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, chlorine, and these are diatomic species. Right? They're bonded to themselves in their elemental state. And there's a reason for this, and I want to kind of glance at it real quickly. And that is, if you were to look first up at something like hydrogen, hydrogen has one valence electron, so it has a dot like that. If you were picturing hydrogen just floating around on its own, that dot is a potential bonding location. This is a really high energy species, and it would bond to something. So if we want pure hydrogen, the easiest way to handle that is for it to bond to another hydrogen. So pure hydrogen, elemental hydrogen, is two hydrogens stuck together. Similarly, if you have something like chlorine or fluorine, these are species that have 7 valence electrons. Just F wouldn't float around on its own, but if you have pure fluorine, you're going to have 2 of those bonded together. And then we come up with the things that have slightly more complicated structures like oxygen. 1, 2, 3, 4, 5, 6 valence electrons. So 2 potential bonding locations, which is why we see things like water. But another oxygen also has 2 potential bonding locations. So if you want pure oxygen, oxygen by itself, we form a bond there, and then we eliminate these bonding locations by forming another bond to oxygen right there. And the last one I want to glance at would be nitrogen, which is 1, 2, 3, 4, 5 valence electrons. Again, that would be an unstable species, and if we want pure nitrogen, we're going to have to bring in another nitrogen, which not coincidentally has 3 potential bonding locations. Alright, so that's gone. Bond there, that's gone. Bond there, and you get nitrogen triple bonded to nitrogen. So we've got nitrogen, oxygen, and hydrogen, and then the halogens, so Han, H-O-N, and the halogens, or Hofbrinkel, or however you want to remember it.